My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 505. In this lecture, we will try to understand EDA basics stats. So now let's go and understand the high level statistics, the basic statistics about the data set itself. So before we go into it, we are just importing a bunch of libraries here. Some of them which we have already learned. There is one very important library very specific to this case study called Network X. You can simply install using pip3. Just see, you can simply install this particular network X using pip3. Install network X. If you are not install network X, you can simply install using pip3 install network X. Let me show you what network X does. So it is very interesting. So network X in Python. So network X is a very nice Python library, especially for studying graphs and networks. You can create a graph. You can create a graph. You can measure lots of properties of graphs. Just see here, you can create a graph. You can measure lots of properties of graphs. So this is a very popular library. Networks is a very popular library. You need not to implement lot of algorithms that are graph specific. So network X gives you most of the popular algorithms, most of the popular computations that you want to perform on network or a graph. So this is a key thing. We would use network X extensively through this case study. Graphs are very popular data structures in computer science. Now given a directed graph like this, if I want to compute length of the path from u1 to u3, I will very easily do that using network X instead of using my own code to achieve it. Similarly, there is a lot of other featureizations of graphs that are very critical to this case study that we compute using network X, and we learn as we go. If you want to get a broad overview of network X, here is the lot of documentation available at our disposal. This is a digraph in degree of u1. What is in degree of u1? How many edges are coming towards u1? Two edges. Therefore, in degree of u1 equal to out degree of u1. How many edges are going or originating from u1? That is 3. Therefore, out degree of u1 equal to 3. Now, having said that, so it's measuring the average. It's measuring the average in degree. Just see average in degree, average out degree across all the vertices. So for every vertex ui, it will measure the in degree and the out degree, and it takes average of in degree and out degrees across all the uis. What it tells in a nutshell is, on an average, there are 5 edges originating from each vertex. On an average, there are five edges coming into a vertex. Isn't it? Very important information, very simple information. Now you want to visualize a graph. Just what is subgraph? Subgraph means, here let me say this is my graph G, this is my graph G, and this H is my subgraph. What is a graph? Set of vertices, set of edges. When can I say H is subgraph of G? If V1 is subset or equal to V, and E1 is subset or equal to E. Here V1 is subset or equal to V, E1 is subset or equal to E. Therefore, this H is subgraph of this graph G. This is simple definition. You can easily create subgraphs. We are creating a simple train underscore wo header means what, without header sample and sample dot csv. We are taking the train dot csv. We are simply saying that we want to only use top 50 rows, isn't it? When we use the top 50 rows in the data set, you can create a sample. This is training without header, train underscore w header, sample dot csv. This is a sample of vertices and edges. Now, if you want to visualize this, there is a very simple. You can literally say plt dot save plt dot save it. You plot, your plot is your matplotlib, your plt is your matplotlib plt. You can just save this figure. You can draw this figure using nx.draw, isn't it? You can draw using nx.draw, and you can give parameters like what is the graph that you want. Is it subgraph? What are the node color? What are the edge color? Isn't it? What is the width of each edge? But you can plot the whole graph. Look at this graph. This is a, what is this? This is a small subgraph. This is not the whole graph. This is only I can say this is a small subgraph. This is not the whole graph. This is only a small subgraph. In this subgraph you have 66 nodes. Just check how many nodes are this in this particular subgraph. There are 66 nodes and 50 edges, 50 edges with some small average in degree, out degree, average in degree, small average in degree, out degree. This is only a very small subgraph. This does not have all the edges. It's a very small subgraph. So what you learned is NX is a very important toolbox, and we learned how to build a graph using network X, and how to obtain some high level statistics like number of vertices, number of edges, in degree and out degree, etc. Also, how to plot a graph, how to plot a subgraph here using nx.draw. You can save this plot we got in the form of PDF. Just I request all of you to go through this lecture. In my next lecture, that is in lecture number 506, I will discuss about EDA follower and following stats. Thank you very much.